Okay. Yeah, in this video, we will see how to find orthogonal trajectories in polar form. Okay. Usually, looking at the polar representation, student gets scared, but it's very easy. One of the interesting problem to the examiner would be some r power n time. Okay, simple. If you know how to proceed with the first step, remaining things will fall in place. The first step would be applying log on both sides. On both sides. Okay. So what will happen? N log R is what I will get. Okay. And then this is U, this is A, this is B. So log A plus log B. Log AB would be sine n theta is what I will have. Now, for orthogonal trajectories, what I should do? I should eliminate the arbitrary constant or the parameter, whatever is there, and then form the differential equation and replace dr by d theta by minus r square d theta by dr, for which, where is the dr by d theta in this equation? No dr by d theta, na? For which I'll be forming the differential equation. How do we form a differential equation? We form differential equation by eliminating the arbitrary constants, differentiating it above equation with respect to theta. Okay. How do you form a differential equation? In the differential equation, there will be no arbitrary constant. So how many ever arbitrary constants are there? That many times we will differentiate. Okay. So what I will have will be n log r derivative is 1 by r. Here it's been given to me that r is a function and theta. Okay. So whenever I'm differentiating r, dr by d theta has to be written. Okay. Log a derivative is 0 because it's a constant. Log of any function derivative is 1 by n. 1 by x. Log of x is 1 by x. Of course, now this is again function of functions. So sine theta derivative would be cos theta. Of course, n theta is also there. So n theta derivative would be n. Now, a is the arbitrary constant that's been eliminated by differentiation. So I'll just rearrange or directly replace dr by d theta by minus r square d theta by dr. Okay. It will look like this: n by r, dr by d theta. I'll just eliminate all the unnecessary things and write it properly so that when you replace, you have no confusion. Okay. N into cos n theta by sin n theta. What should I do for the orthogonal trajectories? In polar, replace dr by d theta by minus r square d theta by dr. Right? So what I'll be getting? N by r into minus r square d theta by dr. This is equal to n cos n theta by sin n theta. Best thing that I'll be doing is variable separable. Separate all the theta terms and separate all the r terms. Okay. So what I'll be getting would be, of course, this n and n also can be cancelled. Right. So what I'll be getting would sin n theta by cos n theta d theta. This is equal to dr by r. Okay. Yeah. With a negative sign, of course. So it is exactly like f prime of x by f of x. Of course, I can put a minus sign here. So f prime of x is equal to f of x, or tan theta, integration of tan theta. I have separated the variables. I'll be integrating. Right hand side, anyways, I know it is log r plus, of course, arbitrary constant. It's an indefinite integral, so arbitrary constant would be log c. Now, this is like f prime of x by integral of f prime of x by f of x, because cos x derivative is what? Minus sin x, right? Of course, I can insert an n as well, because there'll be an n also. Okay. So if I say n sin theta here, there'll be an n outside. Okay. So minus 1 by n log cos n theta, right? On the LHS. RHS is like this. So finally what I'll have will be n. I can take towards this side, towards the right side, or I can multiply with n on both sides. So I'll be having what? There'll be no negative sign. Negative sign will be with sine theta, right? So log cos n theta, this is equal to n log r. This can be written as log a plus b na, n log rc. Log a plus b can be written as log ab, right? So if I cancel log on both sides, I'll be having what? R power n on the R power n. Of course, C power n also can be there. So that can be written as C as well, or C prime. This is what? This is cos n theta. Okay. Yeah. So the final answer, or the family of orthogonal trajectories, family of orthogonal trajectories to the given family of curves would look something like this. R power n, C power n, I can write it as B or 1 by B or something like that. Okay. C power n, I'll be writing it as 1 by B, or 1 by C power n can be B. Okay. So B cos n theta are the family of orthogonal trajectories. Very simple, na? In orthogonal trajectories, the things to focus on is first thing is to replace dy by dx or dr by d theta with something. I have to have a dy by dx in the equation for which I'll be differentiating, or in other words, I'll be finding the differential equation for the given family of curves where I'll be eliminating the arbitrary constant or the parameter. Here A is the parameter. I'll be differentiating how many other parameters are there? That many times I will differentiate. I have a single parameter, so I'll be differentiating only once. And then if it gets eliminated, it is fine. Otherwise, I'll get some value for it, eliminate it in the given family of curves by inserting the value of it. Okay, here anyways is directly eliminated, so no discussions. After eliminating the arbitrary constant or the parameter only, I'll be replacing with the for the orthogonal trajectories. I think I am clear. Okay. Because I'll stop this video.